So we have prepared our cross-linking buffer. So the final step before we do the actual cross-linking is to add this formaldehyde concentrated solution to a final cross-linking solution of 2% formaldehyde. That's our TC buffer, tissue cross-linking buffer. We kept the formaldehyde and then we just invert mix like that. And then we're good to go.
Okay.
So now is the boring part. We need to have 5 ml into each and every one of these. So to avoid that this is kind of starting melting now, because we have this pipette that we have to repeat the process, I'm adding 1 ml to all of them right away. And if you inspect it now, you see that there are some bubbles there, right? Mm-hmm. So basically we are thawing the tissue in the buffer now. I mean, it is what it is, but I prefer doing that instead of having the chance that this tissue is melting, thawing, without any buffer at all. Because when that happens, the nuclease activity just kicks in. The PBS buffer will kind of neutralize many of that. So now we just continue, I think. So now we are kind of, making sure that this is fully dissolved, right? And not just clogged as a pellet in the bottom. So, something like that. Or you can take a small kind of rack and do it there in wort mix. So if you see kind of the pellet still at the bottom, you can't get it loose by doing that. You vortex it a bit. Don't be afraid of that. I mean, it's better to have a proper solution than working with something that you can't pipe it, basically. And that's why we are also using wide bore tips later on, because if you have some small clumps, they will clog your pipette and just slow you down. So it's much better to use those wide bore tips when you have them at this stage. All right. So now is the cross-linking part. And you see, you use this tube and you have this pipette and you're touching the wall. So ideally have a separate pipette for this work inside the fume hood. Okay. So now we have added the formaldehyde. So now we are making sure that these tubes are tightly closed before we do any vertical mixing, because we don't want to have this splashing of this formaldehyde solution. Okay, if you look at it, we are still good, right? Mm-hmm. It's kind of a uniform solution. You see the colors are slightly different, and that's because of the different input amounts. Mm-hmm. So 5 to 10 times, something like that. Yeah. And then we just leave it here, start the timer.
20 minutes.
Yeah, so now we are cross-linking for 20 minutes. Okay, now we are cross-linked for 20 minutes at room temperature. Then we are stopping the cross-linking by adding this stop solution 1 into all tubes. It's about 290 microliter per sample on the standard input protocol. If you incubate for a few minutes more, it's not critical. So you have time to handle your samples within a reasonable time frame without getting too stressed out. So basically we're doing the same as we did for the cross-linking. We cap the tubes properly, and then we mix by inverting 10 times approximately, or until you clearly see that you have no kind of a clump tissue into the solution. So making sure that you have a uniform solution here with no kind of big tissue clumps makes it a lot easier when we are making the aliquots later on now.
And if there is clumps, you would just vortex?
To a certain extent, yes. Yeah. Because, I mean, this is quite stable complex now. Mm-hmm. So you could also do take a whiteboard tip and try to break it and pipette a bit aggressively to kind of, you know, force it apart. Okay, so we can start the timer for 5 minutes. Okay. This seems good, I would say. They are quite uniform.
Mm-hmm. And would you see if you didn't grind your tissue properly, it would be probably more clumpy?
You would probably see some, you know, some faint remnants of some bread, and it's quite easy to see. These seems to be properly crushed. Good. So the next step is to spin down and get rid of the solution, and then we are adding another 1 ml of PBS. Yeah. And from there we are making aliquots with different volumes, which would represent 10% of your initial sample and 20% or 30%. That's one way of doing it. The other way is to take out that 10% aliquot, which on 100,000 would be 100 microliter, and then you freeze the rest or put it on ice until you are ready. Since we are doing the estimate input overnight, we need to freeze it, and the best thing is to freeze it, well, you should freeze it dry. So then we spin down the rest, remove the liquid, and freeze down the pellet. And then tomorrow, when we have determined the input we are going to using, we add new PBS, resuspend until it's homogeneous, and then we take out that fraction that is needed for our prep based on the input determination. So there are two ways. You can either do the aliquoting right away, or you can wait with it and kind of do it later. We usually make some aliquots I usually make 2 tubes with 100, and then 150, 200, and maybe 300. And then I have the bulk of the rest. Because very often I found that you are in the lower part of the spectrum.
So those aliquot you will choose to take forward to the library
Yeah,
stage, depending on the calculation from
yeah.
the
Yep. So there we go. We have spin down our sample. So now we have a nice pellet at the bottom, cross-linked. We need to get rid of the stop solution and the cross-linking buffer. So we are either pipetting off or pouring it off. Depends a bit how well these pellets stick to the bottom.
So it's risky.
It's could be risky. On the other hand, we have 6 samples, so we could test with one.
Of course, yeah.
So I would do that. It's a lot of pipetting otherwise.
Yeah, you did a lot already.
So you can hold the tube like that, right? And you have to pay attention when you do this. So you can't do that. So you have to find a way of looking.
The pellet?
Like that, right? And we are good. This is probably the number 4, is the lower input one of these, right? You clearly see that the pellet size is less than the other ones.
Yeah.
And now we are dissolving this in 1 milliliter of PBS. It's very tempting to vortex now, right? Because strictly speaking, I think the tissue will handle it just fine because it's cross-linked and everything. But I would start something like that and see what's going on, right? And this doesn't come easily apart. So it's a demo of how you make whiteboard tips.
When you don't have any in the lab.
Nice.
It's also much cheaper.
So once again, with these long tubes, there's a risk that we will contaminate the pipette. So that's why we want to have separate pipettes for this kind of work. So I will go in the bottom of the tube and just kind of do some manual stirring there, and then you start pipetting up and down.
Okay. Nice.
And you do that until you are pretty confident that you have a homogeneous solution with no major kind of clumps, easy visible. There might be some, but it is what it is. Then you just go on. The important thing now, if you do not have a homogeneous solution, is if you make the aliquots, they won't be kind of accurate estimates. If you have a very clumpy aliquot, it's probably more than you think, right? So keep that in mind. That's why we want this to be as homogeneous as possible. Because now, ideally, I should have a smaller tube ready, because it's already kind of mixed good, this one.
Okay.
And then I would just take 100 microliters and put in a new tube. That's the tube I'm going to use for the estimate input amount later on. Okay, so now we are resuspending our crosslink pellet in PBS, and we are taking a 10% aliquot to do the determining input amount. So first we just make sure that this is properly resuspended without any big clumps or anything. So I just pipe it up and down. No, this seemed fine, right? So the thing now you shouldn't take a break to do the 10% aliquot. So you do it right away, because then you have a homogeneous solution, right? So otherwise, the 10% aliquot might be 30 if you take a break now. So then 100 microliters, put it in the middle, sucking. The fact that I can suck with a narrow tip, it's a good indication that this is pretty homogeneous without any clumps, right? There you go.
Oh, 10%.
One tube with 10%.